take out your highlighter and you can highlight the fundamental counting principle. What is the fundamental counting principle? Well, this is how you'd write it out in words. If there's n1 different objects in one set and n2 different objects in another set, the number of ways of choosing one object from each set is n1 times n2. Now, the way that I described it to you in the example is we are going to put a space, and each space, this one is decision number 1. This one is decision number 2, and then decision number 3. So each space represents how many decisions you need to make. And then, for each decision, the number you put in that space is your number of choices for each of those decisions. Some decisions will have more choices than others, right? This morning, I had to decide what outfit I would wear. Now, when you look at me this morning, all you can see is shirt, pants, and shoes. So, assuming, well, no, we won't go there. We'll just worry about shirts, pants, and shoes and how many decisions they have to make. So I have 3 spaces. What pair of shoes I'm going to wear, what pair of pants, and what shirt. So I go into, and just to help us realize what our decisions are, I can write, what did I say? I said pants next. Right. So how many different outfits do I have? So I go and I look, and I've got my volleyball shoes, my soccer cleats, my indoor soccer shoes. I've got my nice pair of black shoes, my nice pair of brown shoes, my casual gray shoes, my other pair of casual gray shoes. I've got a green pair of shoes. I should really throw some shoes away, but I probably have 11 pair of shoes at home. Okay? Then I go and look at my pants. Okay, I've got 2 pairs of jeans. I've got brown pants, black pants, beige pants, green pants, blue cords that I'm wearing. I probably, if I went into my closet, I probably have 14 pairs of pants. Okay? And then for my shirts, school, I should probably wear a collared shirt, but I have my long sleeve and my short sleeve. I probably have 20 different shirts. So I would multiply all of this together. And in multiplying all of this together, wow, I don't know if that's the right number, but I would have 3,080 different possible outfits that I could wear to school. So if I went random, I wouldn't have to wear the same outfit. You'd never see me in the same outfit again until 3,080 school days had passed, right? It just happens to be tomorrow I wear my nicest long sleeve shirt with my sweatpants and soccer cleats. That could be a possible random outfit, right? Some of these outfits we never wear because they just don't go together. But if we wanted to count all the possible ones, did anybody check that mult?
Yeah, it's right.
It's right? Okay. If we wanted to list them all, see, we have 3 decisions to make, and then we put our number of choices. And that number of choices could be different depending on how many choices you have for each thing. So when we get to example 2 here, right? And this is one of the applications of this unit. We have to think about how many passwords are possible. How many license plates are possible? Why does Ontario have an extra letter in their license plates than we do? Because they ran out of choices and had to make more, whereas we're okay with the number of choices that we have. So for online banking, we've got minimum security standards to have 2 letters followed by 5 digits. All letters and digits may be used more than once. How many passwords are possible? So in this case, 2 letters, letter, letter, those would be 2 decisions, followed by 5 digits, 1, 2, 3, 4, 5. We have 7 decisions to make when making our password. Okay? And how many choices do we have for letters? How many letters in the English language? 26. And then 26. And then how many digits in the English language? 10. Because you would include 0. 1 to 9 plus 0. So 10, then 10, then 10, then 10, then 10. So we would multiply this all out. And someone check my math. That's right. So if you multiply, if you were trying to guess my password, right, then that's how many different possibilities there are. So your chances of guessing it right away wouldn't be very good. Unless you're predictable, right? If you're predictable, then I'm like, oh, I'm going to try his password. And sure enough, I get it right on the first time. Whose password did I pick? Right? And some people do that, right? They'll just, oh, I'll just use my initials in the first, just 1, 2, 3, 4, 5, then I won't forget it. Because nothing's worse than making a password and then not being able to remember your own password. So we often, sometimes choose passwords that are too easy. But I like it when I'm at a place where there's Wi-Fi and it needs a password, and I'm able to guess it in 1 or 2 tries. That makes me happy. Okay, ones for practice on this one. 5, 7, 8, 9. 10 and 16. And I put a star by 16. Why did I put a star by 16? Because it's so fun or so hard? Ooh, because it's interesting. Okay.